Continuing on solving radical equations, this time we're doing cube roots. So one thing they change on us is instead of actually writing the radical, they say 6x minus 3 to the 1/3 power. So just be reminded that when you see fractional powers, the number on the denominator, that's your index. What's in the parentheses goes under your radical, your radicand, if you will. And then your numerator would be what you would raise everything under the radical to. So if it's just 1, you just leave it alone, you just put 6x minus 3. So minus 4 equals 0. You don't have to rewrite it with the radical, but if it's easier for you to think of it this way, yeah, you can. Other than that, everything is the same as yesterday. We want to get a radical by itself. So I would get rid of plus 4 to both sides. So that gives me 2 cube root 6x minus 3 equals 4. And then I want to get rid of this times 2. So I'm going to divide both sides by 2. So that gives me cube root 6x minus 3 equals 2. Okay. Now to get rid of a cube root, the opposite of that, as you probably guessed, is to cube both sides. Right? So it's going to leave 6x minus 3. On the other side, 2 to the 3rd power, 2 times 2 times 2 is 8. And then we just solve for x. So plus 3 to both sides. We know how to do this. 6x equals 11. Or x equals, we divide both sides by 6, we get 11. 11 over 6, well, that's not a great answer. Say, Ellis, did you mess up? You got a fraction. We don't like fractions. Let's find out. So I can always check my work. If I just plug this value back into my original equation, so this would look like 2 times 6 times 11 over 6 minus 3 to the 1/3 power minus 4. Does that equal 0? Okay, so if I do my parentheses first, so 6 over 1 times 11 over 6, those 6's will cancel out. That's just 11. 11 minus 3 is 8. So we have 2 times 8 to the 1/3 power minus 4. Does it equal 0? So the cube root of 8 is 2, right? So 2 times 2 minus 4, and hopefully at this point you can kind of see our answer here. So 2 times 2 is 4. Does 4 minus 4 equal 0? It sure does. 0 equals 0. So sometimes you get a fraction, that's okay. Whatever answer you get, you should definitely put it back into your equation. Double check, make sure you got it right. Okay, it's not going to kill you. All right, one more example, because really these aren't that bad. It's just solving equations, which you've done hundreds of times before, just with radicals involved. All right, so 2y plus 3, cube root of that plus 2 equals 5. So I want to get the root by itself, so I'm going to subtract 2 from both sides. So 2y plus 3 to the 1/3 power equals 3. So then to undo the cube root, we need to cube both sides. So the result on the left-hand side is just what was in the parentheses. So 2y plus 3. On the other side, 3 to the 3rd power, 3 times 3 is 9, 9 times 3 is 27. And again, once we get here, you know, sigh, breath of relief, this is baby work now, right? Minus 3 to both sides is 20. Oops, as I make a mistake. Minus 3 equals 24. And then we divide both sides by 2 to finish it up. So y equals 12. Okay. If we check our work here, so 2 times 12, actually let's just write it. It's not going to. We got time. This video went kind of quick. So 2 times 12 plus 3. We want the cube root of that plus 2. Does that equal 5? So 2 times 12 plus 3 is 27. Question mark. The cube root of 27 is just the opposite of 3 cubes. This is just 3. Does 3 plus 2 equal 5? It sure does. Our answer checks out. This has got to be it. Okay? So same deal as yesterday. These are actually even a little bit easier because they all follow the same format of there's only ever going to be one root. It's not like the questions yesterday where sometimes there was a root on the left and right. So it's the same basic solution process of isolate the root in your question, right? Move everything else to the other side, and then get rid of the root by doing the opposite, by cubing left and right, and then simplifying to isolate your variable at the end. Piece of cake. But if you have questions, let me know. All right. Bye.